All right, continuing Unit 3. We have our quiz tomorrow over scatter plots and direct variation. The review today was split up into two. You had this little worksheet here, which is all over scatter plots, and you had the Desmos review, which was over direct variation. So, we will start with scatter plots with number 1A. We have a graph here of diamonds and the price of them based on their size. What we're trying to do is find the equation to the trend line through this scatter plot. First thing we have to do is draw a trend line. So, straight line through the center of all the points, about like that. They're all going to be different. You should have the different answer than people around you. Once we have the trend line, we don't need any of the dots anymore. We can just look at the blue line. If I could erase all those black dots, I could. Or I would. We need two coordinates on our trend line to use in order to get the equation of. Now, any two coordinates will work. It doesn't have to be the black data points they gave me. We want to try to find the easiest points possible. I'm going to choose one down here at the very bottom. I'm going to say that is about 0.13, comma, 200. So that's the first point. I'm going to choose one at the very top. You want to ideally do these far apart from each other. You don't want them too close. The further apart, kind of the more accurate it'll get. That is going to be 0.35, comma, 1050. So, again, it's not going to be extremely perfect. This is just an estimate that we're going to be using this for. So, those are our two ordered pairs. 0.13, comma 200 and 35, comma 1050. Now what I'm going to do with that, down here in the space, is find the actual equation. So, 0.13, comma 200, 0.35, comma 1050. To find the equation, we're using the slope formula and the point slope formula. So y2 minus y1 over x2 minus x1. That'll give you your slope. Subtract the y's from each other. We're going to get 1050 minus 200 is, raise it up a little bit, 850 over, subtract the x's, 0.35 minus 0.13 is going to give us 0.22. And then if we reduce that, we're talking about money here, so a decimal would be good. 850 divided by 0.22 will give us, let's go scratch pad. 850 divided by 0.22, and we have $3,864 per carat of diamonds. So, 3864, I'm going to round that. That is my slope, 3864. Once I know the slope, which is m, I can use one of these points. I'll choose that one. No, that's not b. What am I doing? I got to find b. That's my x1 and y1. So I'm going to use the point slope formula. Y minus y1, sideways 1, equals m, parentheses, x minus x1. My point is going to come from 0.13, comma 200. That's my x1, y1. M is the slope that I just found. So, y minus 200 equals m, which is 3864, x minus 0.13. Distribute and solve for y, and we're going to get 3864x minus 3864 times 0.13 is going to be times point. Well, I'll do the whole thing. 3864 times 0.13 we get 502. I'm going to round it off to 502. With these numbers being so big, I can round $502, $502.32. Those are close enough to the same where I'm okay rounding there. Is it 502? Yes. If they were a lot smaller where the decimals made a big difference, then I would not round them to whole numbers. I'd keep them to the tenths or the hundredths place. And that is y minus 200. I need to get the y by itself, so I'm going to add 200 to both sides. And I get y equals 3864x minus, let's see, negative 502 plus 200 is going to be negative 302. This is my equation that can be used to find the price of a diamond based on how many carats it is. The other part of the problem down here says if I want to buy a 5-carat diamond ring for my wife, what is a good prediction for what it will cost? Well, the equation is all I need, so I'm going to erase everything else. I'm going to take this equation, 3864 times 5 carats minus 302, and then calculate that. So 3864 times 5 minus 302, and it's going to cost $19,018. So let's say 19,018. Again, yours might be very different than that. Well, not very different. It should be close to that. 16, 17, 18,000, 19. You know, within 2,000 or 3,000 would be acceptable. If you chose different points, or if your line of best fit, your trend line was a little different, it's going to be slightly off. They're not all going to be perfect. But that's mine. I'm going to have to look at all of your work on the test to make sure you did everything correctly, because there's not going to be one correct answer. So make sure you show your work. Number 2. Similar concept, except you have to make the graph. So we're going to, let's see, someone's working and making tips. We're going to plot these points. So 7. I'm going to pause this and plot them off so the video is not too long. All right, here's my scatter plot. I plotted all 7 of these points. We're, again, trying to find the equation to the trend line. So trend line is going to look like this right there. I need, whoa, can't scroll. There we go. I need 2 ordered pairs on my line that will give me the equation to this. They do not have to be ordered pairs from over here in the table. They're probably not going to be ordered pairs because it doesn't look like any 2 of these dots are on my line. So do not just choose 2 random points. If you do that, you're going to find the equation of a line that goes through these 2 points. So don't do that. Look at your line, find coordinates that are on your line. So I'm going to go with this one right here. I'm going to make it really big so we can tell which one I'm using. That's this one here, which is 10, 50. And I'm going to choose this one way over here, which is 0, 16. That looks about like 16. The slope formula, y minus y over x minus x. Once we do the math there, we get 34 over 10, which again here we're talking about money. 34 over $10, I have no clue how much that is. That would be a time when we want to use a decimal, which is 3.4. That is my slope. So first part of the problem is down. Now I need to find the y-intercept. I could use the point slope formula. Y minus y1 equals mx minus x1. But there's a shortcut here. If you look at this graph, it is showing me the y-axis. I know this is the y-axis because it is 0 right here. So I can look at this graph and tell what the y-intercept is going to be, and I actually use that as one of my points. It's 16. So my equation can be y equals 3.4x plus 16. Now I could not have used this shortcut up above on the first problem because it didn't show me the y-axis. It showed me a part of the graph that was shifted way over. I didn't actually see the origin in this graph. This is the origin right here. In the other graph it wasn't. So the shortcut does not always work, but it does work here. I got the equation. Now I need to find how many tips to expect. Can you erase all of that? I can find the amount of tips predicted in a 24-hour shift. We'll just plug in 24 for the x. 3.4 times 24 plus 16 is going to be 3.4 times 24 plus 16 is $97.60. Again, you will probably not have that exact same answer. That's fine. $97.60. Number 2B is where we do this whole process on the calculator. So I'm going to walk you through that. You should have your notes that look like this. I gave these to you last week, Wednesday, Thursday, no, Friday. If you don't have them, copy them down now, especially this part. You will need them tomorrow. I promise you, you should bring them. If you have them with you, I will let you use them on the test. This is a hard process to memorize, so bring your notes. You can use them on the test. I'm going to pull up my calculator and walk through this process. So, new document, option 1. Whoa, that was too quick. Okay, new document. We want to start with option 4, lists and spreadsheets. Here's where we're going to enter all of our numbers. Before we do that, though, we have to have a title. This A column has to be titled. I'm going to call it X. The Y column I will call Y. After that, we can just enter in all of our numbers from the problem. Up here, the hours worked is my X. The tips earned is my Y. So I'm going to pause to enter all those numbers in on the calculator. Alright, here is my table. I've entered in all of my numbers. All 7 of them are put in there. Make sure you hit enter on your very last number so that it actually submits it. From there, we're going to add a new page, Control, Doc. We're going to add Data and Statistics, option 5. These dots here mean nothing. These are just random dots. We have to click to enter our X variable on the X-axis. Click to enter our Y variable on the Y-axis, and that's what our scatter plot should look like. It should be the exact same as our other hand-drawn scatter plot because it's the same points. To get the equation, again, all these steps are straight from your notes right here. We are at this right here, menu, analyze, regression, show linear. So to the calculator, we have menu. Analyze is 4. Regression is 6. Show linear mx plus b is 1. That gives me the line of best fit, y equals 2.89 x plus 18.9. So I'm going to round it to the hundredths, 2.89, and then 18.95. So, where are we at? Here we go. Nope, what's going on? I don't know what's happening. What's this? I need you to go away. Uh-oh. Hang on. Okay, I hit a wrong button, but I'm good now. 2.89x plus 18.95. So y equals 2.89x plus 18.95. That is, I'd say, similar to this over here. 3.4 and 2.89 aren't too far apart. The y-intercept, 19 and 16 are relatively close. To make this prediction for a 24-hour shift, I'm going to plug in 24 to my x. So 2.89 times 24 plus 18.95. Let's go back to our calculator. Add a new page. Control Doc adds a page. We want a calculator here, so I can say 2.89 times 24-hour shift, it's a long work shift, plus 18.95, double check to make sure that's right. 2.89, 18.95, yes. Enter, and we get $88.31. So when I come back here, $88.31, which is relatively close to that. It asks me to, how does this number compare? Well, I would say it's a pretty close estimate, $97, $88, at least in the same ballpark with each other. As long as you're somewhat descriptive there really isn't a wrong answer. If you think that's far off, then explain why you think that's not a very good prediction, and you'll be good there. The last question, 2C, what is the correlation coefficient? The R value. Back on our calculator, we have this var button right over here above the 9. Hit var, stat.r, enter 0.96. 0.97 if we're rounding. So back over here, our R value, 0.97. On our notes, scatterplot notes, we had some sample R values up here. 0.75 was strong. Right now we have 0.97, which would be very strong. So anything you would describe here stronger than strong, I don't care what adjective or whatever word you want to use, very strong, really strong, super strong, very strong, positive correlation. And that is it. All right, part 2 of your review was the Desmos, the card sort, all about direct variation. Best math teacher you have ever had will be this little Dalmatian here, right? All right. All right, some vocabulary terms. We have to match all of these. Now, we should all mostly be done with this. You did it in class, but if not, let's just sort them out and find the matches. K, I know, is the constant of variation, sometimes called the constant of proportionality. Those are the same thing. We find K by doing y over x. So those are all a match. I also know that K is the slope. We just call it K instead of M if it's a direct variation. So there's that. A proportional relationship is another name for a direct variation. So we can match those up. The equation for a direct variation is y equals kx. We can match those up. A function that can be put in the form y equals kx, well, that's just a way to describe a direct variation. The origin is the y-intercept of a direct variation. It has to be a straight line through the origin. So the y-intercept can only be 0, 0. So there is page 3, or slide 3. If you need to pause it to check your answers, feel free to pause it. Go through and look at yours. The graphs, page 4. This is the easy one. Straight line through the origin. That's all you're looking for. This is a straight line through the origin. That is a direct variation. This one does not go through the origin. It is not. Here, straight line through the origin. Straight line through the origin. Straight line through the origin. Not. Easy one there. Page 5, we have equations. an equation can be put in the form y equals kx if it's a direct variation. This is where you probably need to do some scratch work. Some of them are already there. This one is a direct variation. I'm going to put it over here. This one is a direct variation. Y equals kx. This one has a plus 4. That has a y-intercept. I know that is not a direct variation. Same with 5x plus 2. That is not a direct variation. So here are my unknowns so far. Let me sort them out here. So I'm going to do some work for them. Let's start with x plus y equals 0. If I want to make this look like y equals, then I need to get rid of the x. If I minus x from both sides, I'm left with y equals negative x. I don't really need the plus 0 because it doesn't have to be there. And that's like a negative 1x. That is y equals kx. That is a direct variation. So I'm going to put that one over here. Or y equals 8x. Again, I want it in y equals form. Divide both sides by 4. And we end up with y equals 2x. That is y equals kx. That one's going over here. I think I can click. I can make it a little bit bigger. That'll help. X plus 3y equals 9. I want the y by itself. Get rid of the x first. 3y equals negative x plus 9. Divide by 3. Y equals negative 1/3 x plus 3. This has a y-intercept. This cannot be a direct variation. It's going to have to go on this side. Y equals negative 3. This sort of looks like y equals kx, but in y equals kx, my k has to be paired up with an x. Here, I do not have an x, which means this negative 3 is actually the, if we have mx plus b, this is the b part. So it would essentially be like 0x minus 3. That is a 0 slope, shifted down 3. That is not a direct variation, so that's going to go over here. So here we have this one. Oh, not you. That one. These two are not direct variations. So, pause that if you need to. Check your answers. We have one more to go. The tables. Tables, I think, are one of the, well, graphs are definitely the easiest. Tables are the next easiest. All you need to look at is the k, which is y over x. If they're all the same, then it's a direct variation. If any of them are different, then it's not. Another thing to check for is we know I need it to go through the origin. So let me find an example really quick right here. 0, 4, that is not the origin. That's going to be up 4. So that is not a direct variation. It's going to go on the right. Whoop, I did not mean to match those up. So, not a direct variation, goes way over here. I have this one right here. Let's look at y over x. I'm going to avoid all these negatives for now and look at 1 over 8 and 3 over 10. Those are not the same. 1 over 8 comes out to be a small decimal, 0.125. 3 over 10 is not 0.125, not a direct variation. Here we go with this car charging and battery percent. 45 over 30 is 3 over 2. 75 over 50 is 3 over 2. 90 over 60 is 3 over 2. Those are all the same. That is a direct variation. So that's going to start over here. I have 4 left to look at. Let's look at this one here. 0, 0, 1, 1, 4, 2, 9, 9, 3. 0, 0 is the origin. Now I can't divide 0 over 0. That'll just give me undefined. So I don't really need to look at that. But 1 over 1 I know is 1. 2 over 4 is not 1. That's going to be 1/2. So this is not a direct variation. This goes over here. I have, let's look at this one. if some of these numbers are confusing, try to make it easy on yourself. Choose the easy ones. Uh-oh. 10 over 1 is just 10. Well, down here I have negative 10 over 5. That is not 10. So that's a 10 crossed off. It's not 10. So that is not a direct variation. I got two more really quick. Speed up while everyone's trying to come in the door. Y over x. 3 over 4. 6 over 8 reduces to 3/4. 9 over 12 reduces to 3/4. And this is a direct variation. Same thing here. 15 over 10 is 3 over 2. 9 over 6 is 3 over 2. If you keep dividing these, 3 over 2, 3 over 2, 3 over 2, this is a direct variation. So put that here, and here are the answers. I'm going to separate these just so you can see them. But these are the non-direct variations over here, and these three are the direct variations there. So that's that. You got a test tomorrow. Good luck. Bring your notes. You can use them. I'll be here for tutoring in the morning. I will see y'all then.